So we talked about pattern recognition. The next part of computational thinking that we're working on is moving from pattern recognition to abstraction. And what abstraction means is it's a data practice that includes the process of identifying and organizing relevant information and removing unnecessary information. So to incorporate some abstraction with our Mauna Loa data of CO2, we might take the data and simplify it using a model that more easily captures trends in the data. And here we see three examples. We see linear, we see quadratic, and we see exponential. These are three types of functions that can be used to model the data. And the questions that you might ask when you're working towards abstraction is, what information is most necessary to answer your research question? Can you filter the data to only show the most important data? Or what's the clearest way of visualizing the data? So if we go back here, it may not be necessary, depending on your research question, to show the seasonal change in carbon dioxide. It may be easier for you to just include this upward trend line. And if your question is around seasonal variation, of course, you wouldn't choose this one, right? Because you would filter out the data, that seasonal change that's most important to recognize. And finally, the last part of our unit involves some algorithm building. So as we move from pattern recognition to abstraction of the data to algorithm building, we really want to be creating a series of precisely defined steps or rules that leads to a successful solution to a problem. So here we have some different kind of data. We have the coronavirus data from Johns Hopkins University. This is time on the x-axis and the number of cases on the y-axis. So really, regardless of the data set you're looking at, you can begin to think about, well, what type of function, what formulas or equation that I can use to make sense of these data. And for our purposes in class, we'll be looking at linear, exponential, and quadratic functions. So that leads us to the video that you can watch in Google Classroom after your first 5. Watch it, take a moment to reflect. How does this fit with what you already know? In what ways is the information in this video new? And how can it get us thinking about the best way to model our Keeling curve data or another data set we might see in science? Once you're done, take a look at that formative on the Keeling curve. It is due today. It was the formative we would have had last Monday. I wish you all happy working, and I'll be around later this afternoon to answer questions via Zoom meeting. Thank you so much. Bye.